colors and things. So this set of folders then is what I use in my as I progress through my image processing. Okay, let me get rid of this one and this one. And when I'm into PixInsight, here's what my programs look like. Let me see if I can grab that one now. Can I look around my area? Hopefully everybody can see my PixInsight page. It may get a little blocked out by our images on the right, which I guess you can close. I like this as my opening page just because this is a young child of one of my good friends, and I sent him one of my images, and that look on his face looking at that image makes me happy. So anyway, that's what I have for starting. Let me see if I can get rid of that so I can see my own images. Get rid of that. And I'm going to kind of go through the set of processes, and these are available. I've put it out on the internet. Hopefully all of you have gotten a link to it. Since I sent out the link, I've made some small changes to it in terms of which icons I've annotated which way and things like that. So you could download it all again if you wanted. If not, that's fine too. It's not, I didn't make major changes, so that's it. Okay, so these are all the processing icons, and you can see down here, the last thing I do is crop and annotate an image. And before then, I do some final touches in external programs. And then very often these external programs will introduce an alpha channel into your color images, and you don't want that, so you remove that. But I'm getting ahead of the story. So let's go up to the top of this, and I'm going to go through a set of icons. And maybe when I reach one of these horizontal lines, these are the sort of the changeover point from one kind of operation to another. And we can pause for a minute and see if there are any questions after reaching one of these. To start with, I have a no-op, icon from PixInsight that doesn't do anything, and it gives me a place to put my title for my processing image, so I can remember that I'm doing NGC 6072 in this case, that it was done on the plane wave 17-inch by data from Deep Sky West, and located in Chile, and it's an RGB image. Of course, you can put anything you want in there. You can, sometimes I don't put anything, but it's handy sometimes to know what you're dealing with. The next thing I do, which probably most people don't do, is I set up what's called the RGB working space. And that icon looks like this. And all it is a set of coefficients that you have for the red, green, and blue channels. The defaults for this, I'll show the defaults here in just a second, favor green. And so it puts most weight on green. Most weight when doing what? When extracting L, for instance, from the image. It would weight green very heavily, red quite modestly, and blue almost no weight to it at all. This is supposedly in relationship, or the coefficients that are really there. Let's see, here they are. So 71, almost 72% of the weight goes to green, 22 to red, and only 6% to blue. Well, we don't have a lot of green in our images if we process them correctly. So putting 22%, 70% weight on green is kind of useless. So those the other values I showed you were some recommended by Juan Conejero. I hope that's how you pronounce his name. If not, I apologize to Juan. And he suggests that maybe these are more appropriate for producing L in operating on our RGB images. Now, what else is used for besides extracting L? I would suspect that it's used when blending L into an image, which I hold is a useless operation. But if you insist on doing it, you're dropping, then if that's true, you're dropping 72% of your L image into the green channel. And that's not very useful because there's not a lot of green there to emphasize in your images. Anyhow, other than that, the documentation really doesn't say what you do with it. But when you go to an external program, it's almost sure to have coefficients very much like this. And you can see some of the distortions in the colors that are caused in other programs. Like if you use this one single image high dynamic range transform, it will put a lot of green into your images. And so I set this to those values I showed you, to those values, which are the ones Juan suggested. And with all my icons almost up here, anyway, almost, there's a little red D in the bottom. If that D is red and not black, then there's a comment in them. And so, for instance, this one has a comment about the values. This is an older version, and I have a little bit better comments than the one you would download. But anyway, this is probably more than you want to know about each icon, but it's a guide and will help you if you're unfamiliar with what it does. So that's a sort of pre-processing step. Before you start, you're just setting up PixInsight to do what you want. The next thing I do is blink the images. I don't have an operable icon for that because you can't produce an icon out of the blink process. So you have to go into process, image inspection, and blink. And there's the blinking thing. Here it's all loaded up with all the RGB and a few H images. And it's important to blink your image. You see there's no little triangle down here, which is what you drag off to get one of these icons that I show you. So you can't do that with this. It's important to blink your images for a number of reasons. You want to get rid of images that have a lot of trails through them, especially thick trails, satellite trails, or airplane trails, because those, while we're supposed to have been stacking, get back to something that's more representative of the image, but they leave artifacts behind if you stretch your images hard and go for great detail in them. Those trails will almost always show through unless they're fairly faint and 1 pixel wide, maybe a pixel and a half or so at the most. So you get rid of those things out of your data set. Also, you want to look and see if there's anything like an image that's where the target sits way off to the side, something that wasn't put into the center that you want all your images to be more or less centered. Of course, there's dithering, but ignoring dithering, you want your images centered. And or if you're an artist, you want them in the upper third. But for most of us, we center them. You also want to look at your stars on each image and make sure that they're fairly round. We'll get to more of judging the roundness of the stars and measuring the roundness later and using that as a factor in weighting the stars. You also want to make sure that there weren't high clouds, so that one image has all of these stars you see in it, and the next one has only a few stars in it. You want to throw out the bad images that were clouded or caused by clouding. So tracking, clouds, and focus is another thing, of course, that you want to look for. And once you've blinked all the images, thrown them away and stored them in the file I showed you earlier, or on the blink file, you can move on to the next operations. And for me, the next operation is to calibrate the images. I probably do this differently than most of you do. Takes a little while for it to come up. I do the normal calibration of bias, darks, and flats. Sometimes you don't need bias if you're using a CMOS camera, but darks and flats, and then the lights, RGB, HSO, all of those. And then I check in here on the calibration tab and make sure that there's some check marks in the status. If not, I find out why it hasn't put a green check mark here. It's because it's missing something. One of these subframes is either missing, or it, for instance, if you had darks that were of a different, your calibration darks didn't have the same exposure as your light frames do, it'll warn you about that with a check or a lack of a check mark here. And you'll have to do something to repair that. It's pretty easy. I won't go into it here. And I specify the output image, the output file. That's all I do in here. I don't do any stacking. I don't do any weighting. I don't touch anything else. That's it. Input the things, specify where you want them to go, make sure it's all set up, and run it. And I'll explain later why I do this. But I don't find all those additional steps that you can do in here, like weighting the aligning the images and weighting the images and even stacking the images, I believe, is now possible. I don't do any of that in here because I want more control over what I do in the steps that follow. Then, like I said, I can downsample the images if I want to. And one of the things you do when you downsample an image, these are downsampling all of the subframes. So you have a downsample image that says I'm going to go down 70% in this case. And I use something called an image container, and you drop all the images into this area, or open a file, open a folder, and put them in there. And then you specify the output directory, and you put a file name and extension. And then when you drop this little blue triangle onto the bottom, this area here, of the resample tool, you will, one at a time, resampling will transfer it to this algorithm, and it will do the resampling and store the images off one at a time to this folder. Image containers are a very handy thing, and you may use them for all kinds of operations, particularly when you have lots of subframes that you need to handle one at a time. You certainly don't want to go through a modern set of images taken with a telescope, maybe 40, 50, 100, or several hundred subframes, and one by one downsample. Okay, then the magic of something else. I run subframe selector, and and when you invoke it, you get these three windows that come up. You drop the subframes in that you want to measure into here, and you do that by one filter at a time. So here we have the green ones loaded up. You have this set to measure subframe, and by clicking it and pulling that down, you set some output directory and a keyword that's going to put the weights. Now you can do this weighting inside of WBPP, but when it weights it, it only does one thing. As far as I know, you can choose, as I understand, you can choose number of stars, but most people choose a noise, one of the noise parameters, like, I don't know, they're associated with the point spread function of the stars. The problem with that is there are multiple factors that enter into an image's quality besides the noise level in the image. Like I said, blurring is one of them. Another one, of course, is clouds and things like that. So I want to have the ability to examine several parameters at once and put them into an equation, which goes down here in this, and weights the images and rejects the images. And here the red ones are rejected images. And on this plot of the values of the various parameters, you can change what you want to see here: full width, half max, number of stars, or anything else you want to see. Okay, so that's fine. I want to do this, but how do you do it? Because this thing, where do you get this equation from? This makes the measurements, And if you click right here, you can save the output from this into a comma-separated file. And that comma-separated file can be read into Excel. And that's where I get my equations, is out of Excel. I'll show you that. Hold on a second, because I think I have to drag it to the screen. Yeah. Here's what I use. This is a Excel spreadsheet that I originally wrote, and a gentleman by the name of Jim Hunt in London made it usable. And so this is our combined effort at this operation. Now, from inside this, you can open that CVS file. Unfortunately, I didn't get it pointed to it. That was done. Which one is it? It's this one. Intermediate processing. And this is, and we didn't select it, and there they are. Okay, so you open up the file, it reads in this comma-separated file and gives you a number of plots. This one's very simple, the weight and the frame index, the number of the frame. But where does it get the weight? You set variables that you want to use in the weighting. For instance, full width half max. There's drop-down menus here. So, and eccentricity, or you could change that to something else. And this point spread, signal weight, or you could change that to something else. And the number of stars. And what it does, you can then change the weights you want to invoke for each one of those in coming up with the equation. And you can change the gamma stretch and some other things. This is all documented. This Excel spreadsheet is out on the internet, along with the other things I supplied for downloading, along with a user's manual, a few pages describing how to use it. And it not only weights the average images, but it gives you an idea of why it has that weight. So here's full width half max plotted against the number of stars. It always plots against the bottom entry in up here. And so there's, for instance, you can see there's a strong correlation between this number of stars and the full width half max. Interestingly, it's a negative correlation, which means that the more stars there are in the image, the smaller their full max half width is. And that's a good sign. That probably means that you're seeing more stars because it's focused better and there's not much turbulence in the air. And so, but it also means that you probably don't want to use very much weight up here for full width half max, because it's just mimicking the weight you're giving to the stars. On the other hand, eccentricity scatters a bit, but it's uncorrelated and it's not organized. So it looks like you don't need a lot of weight for it. You just want to get rid of some of the abnormal stars. This high one here, for instance, high eccentricity. The main thing I've weighted here is the number of stars. And so it's also thrown out the images with the smallest number of stars. All this is adjustable, and you have to play with it a little bit to decide on what stars you want to keep and what stars you want to throw out. And you can see here, this point spread weight, signal weight is correlated pretty well with number of stars. In this case, it isn't always. And so you would get the same result whether you use my equations or this one, except you probably wouldn't throw out this bad eccentricity one in this particular case. There's more information down here about the correlation coefficients and what have you, but I won't delve on that. And there's one here, a page for B, a page for G, H, O, R, S, and L. And so you can make these kind of analyses on all of them. When you save the images, output the images from here, from there, I'm sorry. When you can copy that equation you come out with here, post it into here, click the little arrow, and it will weight your
Alex,
yeah,
can you take a question?
sure.
So can you just summarize what your very sophisticated Excel sheet does that you can't really do in just the basic subframe selector?
In some
I can
frame
have approval
selector,
weightings, I can weigh them, I can reject them, you know, what
yeah,
more are you getting?
you can't write this equation from
Why do I need that equation?
because this it allows you to balance various parameters, like how important in this data set is the eccentricity or the full width half max or whatever, versus just in this one, if you just said, okay, I'm going to just use number of stars, that's fine, but you wouldn't throw out then the bad eccentricities.
Well, so I don't know how much of this would be interesting to see how the results would differ, but I generally look at a range of full width half maxes and decide what I can accept. It's plotted right here. I take eccentricities of less than 0.5, and I run the thing, and those are the files I use.
Yeah, this allows you to examine many more parameters and to assemble them in a logical way and to see what the consequences are going to be beforehand. And I think, for instance, my main parameter in virtually every image I've ever processed is the number of stars, because all of the defects in an image feed into the number of stars that can be recognized. If you make a star, if you have poor tracking and you make elliptical stars, that reduces the total intensity at the centers of the stars. It darkens the stars, it dilutes them. And if same thing happens if you have clouds going over, your full width half max with clouds going over will reduce and look really good. But then when you look at the number of stars versus that, you'll find that the number of stars has also dropped. So it's a better full width half max, fewer stars means that full width half max is being affected by focus, by clouds, by other things, and it's not a reliable measure. This, with a little practice, allows you to interrogate your data better. That's the main thing.
Thank you.
Yeah, sure. Hey, we can take a pause here. Anybody else have a question? Okay. I'll go on and to the next one, and that's star alignment. And I always pick out from my spreadsheet the image with the most stars and the highest weight assigned to it, and use it and as the one that I align to. I rename it align to in every case. Then I just drop the other files in here, specify the output, and I get the aligned images aligned to the best image in the bunch by the equation that you developed. Pretty straightforward. And again, we emphasize that all of these have some sort of discussions associated with them. Okay, I use normalized scale gradient. Again, in the weighting, I guess you can do your normalized scale gradient there. I'm not sure. And you can do it in PixInsight. It has an algorithm for doing it. I use the one that's, I forgot who wrote it now. But anyway, it's one that is a auxiliary one that you have to purchase. And it's pretty inexpensive because, again, I have more control over what I select for the reference image. In PixInsight, the reference image is selected automatically, but I can go back into my spreadsheet and see which was the best one for the red, green, blue, etc. And I can choose that as my reference image, which one I had the most stars, least ellipticity, etc. And I normalize the data. And then normalization means that you're putting, it goes through the image in small chunks. And it takes those chunks, looks at the star brightnesses in that chunk, and makes them somehow coherent with each other so that they're all are more or less look like samples from a standard distribution, a normal distribution. And then the pixel rejection in the next phase of our operations will be more valid if you have normalized images than if you don't. Because if you have an image that for some reason is slightly brighter, if you had maybe different exposures or things like that, the brighter images will be treated differently. There's assumptions behind almost everything that has a statistical bent to it, that the distribution of the values is normally distributed. And if they aren't normally distributed, almost all the valids, all the operations that you perform in the data are in fact invalid. How invalid depends on the particular instance, but none of them are robust against being non-normally distributed. So this helps you toward a normal distribution, helps you toward recognizing noise from signal. Okay, and then you calibrate your images. I'm sorry, you integrate your images. And I use this generalized extreme student deviation. I don't know too much about it. If you can read a bit about it here, and you can read more on the documentation on the PixInsight page. But overall, for most data, is according to Juan, is the most reliable. So that's what I use. Now, if I have a small number of data points, like 4 or 5 images, rather than using average, median is more robust. It was give you a better estimate of what the true underlying image values are than an average. If you use local normalization, like I just did in the previous one, generate local normalization, then you select that here, and you select that here, and then you have to add normalized files to your integration. All that's straightforward and easy to do and documented. Crop the images after you stacked them. Usually because of dithering and things like that, some areas around the edges may be blank. It's possible, or undersampled and noisy, and you want to crop those off. And I crop all my images at this point, all the RG and B individually. Then I do a background extraction, try to flatten the background so that gray over here is the same as gray over here. And that's necessary also to get good color balance across your images. You can do it either at this point, or you can do it after you make an RGB image out of it, color image of any kind out of it. I like to do it here, but I think you get the same results if you first do an RGB combine and then do it. On my set of icons here, the operations, you proceed from left to right, top to bottom. And so they're spaced out like this, cropped, blank. Then you do this. If they're not spaced, it means that the two of them do pretty much the same operation, or they're substitutes for each other with slightly different outcomes you're going to get. So this is the dynamic one, which means that you're going to interact with extracting the background. This is automatic, which means you click a button and away it goes. The dynamic in general is better because you can place the sample points onto true background sky instead of having them just scattered around the image where you don't know where they are, and they might be in the middle of the galaxy or elsewhere. Okay, so after you flatten the images, I do a linear fit sometimes, and the linear fit will balance the RGB to a certain degree and make so when you make this color image in the next step, RGB combined, it will have a reasonable color balance. It won't be right, but it'll be more reasonable than if you just left it without the linear fit. Now, actually, linear fit ends up for most RGB images is not necessary to do, because even if you combine it and the image looks totally green or totally blue or whatever it comes out looking like, once you color calibrate it using photometric color calibration down here, it will remove that and go back to a calibrated color image, a correct balanced color image, regardless of whether you did the lunar fit first or not. The other thing, if I have any narrowband images, I use another script, and this one I wrote, and it's called a narrowband assistant. And what it does, I'm not going to go into details. I think I gave a talk on this a while back, but it combines the RGB with the H, S, and O, or if you only have H, S, and O, it'll make a image out of those, or it will take RGB, H, and O, or whatever, and make a color image. Main thing it does that's different than anyone else's out there is, if you know anything about spectrographs and spectrography, is that there's a thing called a continuum, which is kind of a background color variation or colors behind everything. And then there are parts of the image that have emission lines, the hydrogen, oxygen, sulfur emission lines. And the emission lines are added to that background. So when you put a hydrogen filter over your image and over your camera and take a picture, you're sampling the hydrogen emission line plus the continuum that is in that area of the spectrum. So you get them both together. Well, this program removes the continuum as best as possible, and it doesn't do it in some arbitrary way. There's one program out there that says you just subtract a percentage, you make it up and you subtract it. I want to subtract 10% and call that continuum. That's not very rigorous. This one solves 2 or 3 simultaneous equations that relate to the spectra. The image is captured through different filters, and you specify filter parameters in order to get those, and exposure parameters in order to get those 3 equations to solve. And so it's really just using the emission line and throwing away the continuum. Is it perfect? Far from it. It's the best thing out there, no doubt about it. Again, this is available in that download. There's as well as some documentation on it, but that's what I do to combine, and it makes a true color image. And so it maps those the hydrogen and the sulfur back into the RGB and the hydrogen alpha and sulfur into red, the oxygen into a teal kind of color, and it even has the ability to add in some blue from hydrogen beta, even though you didn't measure it. Hydrogen beta in most nebulas makes up about 35% of the emission from hydrogen. Where there's hydrogen alpha, there's always hydrogen beta, and it varies a little bit, but it's around in that range. And all these things have sliders, so you can adjust them. Okay, that is all I'm going to say about that one. Anything else? Any questions? Okay, then the next thing I do is usually the alignment image, the image you align to, has coordinates in it. So I've now got an image that is an RGB image, and I copy the coordinates into that new RGB image. Or I plate solve it if I have to, using the standard tools we have in PixInsight. These are both scripts rather than details, so they lie up here. Utilities and copy coordinates, and the other one is under image analysis, image solver. Then I do a photometric color calibration. It looks at the stars in the image and says, I know what color those stars are supposed to be. They've been measured by professional astronomers, and I'll make those as best I can, those same colors in your image. And it does that. Now, PixInsight has come out with a spectrographic color calibration tool, which immediately hit and became the rage. The documentation on it isn't good, and I can't say that what I'm about to say is absolute truth. But a spectrographic color of a star is not necessarily the same as what it appears. And what it appears as is the photometric color. Spectrographic color, you would take a spectrum of the star, look for its various lines, determine what its size and age are, and calculate its color from that, which is just fine, except if there's an intervening cloud somewhere between you and the star will be reddened, and its true color, therefore, is not the spectrographic color. The color you see and you photographed is not the spectrographic color, it's the photometric color. So I always use photometric. And of course, if you use the wrong colors, it makes your nebulas the wrong colors too. Okay, another thing, even though you can neutralize the background here, that is, take the area between the stars, some area that is dark, and make it neutral in color, gray scale color, rather than red or green, you have to find an area and make sure that you assign that area as your region of interest, and you make a preview and then tell it what preview you're using and as the area that you want to make neutral. Or you can do it in a separate step, background neutralization. We've all probably played with SCNR, which is a noise reduction tool. It's particularly useful for taking out green in the images. You want to take out as little green as possible and to make your images look good, that is kind of neutral in the areas that should be neutral. Even the background neutralization doesn't do a total job in many cases, does in others. So a little bit of SCNR helps, usually not 100%, maybe something between 50 and 75. And finally, these tools that were developed by Russell Croman, Blur Exterminator, and his other programs work quite well, really excellent. This is Blur Exterminator is always done before you stretch the image and done before you remove the noise from the image. If you remove the noise, you may also be removing data from around the star, and it may not do a very good job of removing or making the star smaller, sharper, and sharpening other features in the image. So you always do it before stretching and before denoising the image. If you haven't done it yet, Russell Croman has on his site the best method I know of installing the NVIDIA drivers so that this program will run using the AI capabilities of your video card. And that changes things. That's a game changer in big time. If you install those, the program, my computer went from running for maybe 3 to 5 minutes to running for 5 seconds. And that means that you can actually undo it and redo it many times if you don't like it, and get the exact image you like, rather than being frustrated by having to sit there for 5 minutes while the program runs. So you may want to look on Croman's site and see about how to do that if you haven't done it already. Well, the next thing we do is stretch the image. And this whole row here is all the stretching functions that I use. The one that's missing is, what's it called? A generalized hyperbolic stretch, GHS. I don't use generalized hyperbolic stretch. I find it confusing and frustrating. And I can do exactly the same thing with a combination of curves and histograms as I can with that, up to the level I need it. We're now talking about getting a stretched image, and the details of the stretch, what areas are brighter, what areas are less bright. I do after I've stretched the image, and I don't do it in PixInsight, I do it in another program. So I don't, and it does it better than the histogram, generalized histogram method, and generalized hyperbolic stretch method. And so I don't use it at all. If you want to use it, it's absolutely fine if you can handle it. Arc sine stretch is an interesting one. It has the capability, the way it operates, and there's an equivalent actually in the generalized hyperbolic stretch. The way it operates on the data is one channel at a time rather than stretching all of them together. And because of that, it brings out tremendous amount of color, both in your nebulae and particularly in the stars. And so I use that to do a kind of first stretch, maybe halfway up the stretching spectrum. I use that to get the star colors into the image. And then I go to something else. Usually a mass stretch, but sometimes one of the others methods. After that, I use noise exterminator, another Kroman development. But there's another one called Deep SNR, which is in the normal repertoire in etc. of all strange places on the PixInsight method. And here it is. And that one also is a noise removal artificial intelligence program. I don't think it's as good as NXT, but NXT costs some money. This does not, and this does a pretty darn good job. Once the noise is out, I remove the stars. Star Exterminator, another Kroman one, does a superb job. A free one, which is again on your PixInsight distribution. Star Exterminator, somewhere in here. There's StarNet 2. And it does a credible job, not as good, but neither one of them is perfect, in fact. So I removed, obviously there, I'm removing the stars. What is it? Oh, there's the hyperbolic stretch. Got it kind of on the wrong line. Okay. And then once you've removed the stars, I do some alterations of the extracted stars because I don't want the stars per se. It extracts the stars, they'll be the wrong color. Or your reds will be too green if they're on top of a nebula. And when you put them back in, they'll be the wrong color if you stretch the nebula or affect the nebula anyway. So all I do is I make a mask, a grayscale mask out of it. And that's this just uses pixel math. Here's the input image, and I just rename it to transfer mask and change it to grayscale. So I can just drop that onto it. And then I adjust it because it's too dark. It'll never transfer the stars very well. And finally, then I go off onto other programs and I do my post stretch processing. Particularly, I like Topaz Studio 2, and I'm starting to, and I use Aurora HDR sometimes. There's another program out there, actually out of Russia, called 3D LUT Creator, and it's really good for adjusting colors of certain colors. It shifts colors around as you want. Very, very good. It's got a steep learning curve, however. And then I come back in and I restart the images again with another script that I wrote, which is also provided. And all you do is put in the image you want to target. Star source, that's your RGB image, for instance, after stretching. And the starless image, the one, so this is the image, this is the same image with the stars we removed, and here's the transfer mask. And then you have some adjustments. And this method is different than anything else out there because it doesn't transfer them by a blending method, screening, unscreening, or just simply copying and pasting. are all blending methods. And so you get a combination of the color of the star and a combination of the colors of where the star came from and where of the colors where the star is going. And this does a more pure job. It's called alpha compositing, and it effectively paints the star, picks up the star, kind of unpaints it if you wanted to, and then paints it onto the image so that it has its same color in the final image that it had in your first stretched image. No mixing involved in that. So it's kind of unique. Again, it has instructions associated with it when you download. That is my whirlwind tour, and it took even longer than I had promised Greg I would do, and I'm sorry, Greg. But I'll be happy to answer questions now. No questions? I'm going to stop sharing.
Hey, Alex.
Keep it up.
Alex? Yeah, this is Kevin.
Who's
This is
talking?
Kevin. Kevin.
Okay.
Yeah, I was just curious. Is this still evolving, or is this something you've sort of gotten to a point where it's about as good as you need it?
What do you mean? Which part of it? All of it?
Well, all of it. Yeah. I mean, the whole.
No,
I mean, it looks like a really interesting way to organize your workflow, and I'm just.
I use the same one every time, but it has variations. Sometimes I change the order in which I do things, a few icons left, right, up, down. But it's basic. It depends on the particular operations that what the image requires. And sometimes I go out and grab another icon, but it's certainly the base template. Now when I use this template, and I've used it for almost a year now, it takes me 3 to 4 hours to process an RGB or RGB HSO image, so to the state of having it stretched image, and that's fairly fast. And so I can process an image start to finish, including the post-processing, in about 6 hours. So doing an image a day is pretty good. When I started out in PixInsight, it was a week to get it done. Now it's 6 hours. And like I said, all this is available. I published the link on our website. If you don't have it, and for some reason it's not there, you can write to me directly. It's pretty easy to write to me. Just try Alex at Faint Light Photography. One word, no spaces anywhere, underlines, or Alex at Faint Light Photography, and I'll give you the link.
Alex, I have a question.
Yeah, Mike.
I had to do it right at the end of your presentation. You're talking about unscreening versus painting these stars. I have never done anything like painting. I always use Russell's unscreen option when I take the stars out. And sometimes I actually work on the star's image, but adding saturation, maybe even adjusting size a little bit more, and then I screen them back in Photoshop. Tell me why that's so bad again, because I kind of like my stars.
Both screening and unscreening are unblending and blending, and which means that you're adding background and foreground, or target and background, however you want to put it. You're adding portions of each of those to the final image. And that's stars are usually in the foreground and swamp the background. So you don't really want to mix those two colors or even other things together. The painting is totally different than it's really called alpha compositing. And it's a set of equations that allows you to extract the exact colors. And it's not available in Photoshop or any other thing I've seen. I did a lot of research on the internet and found this alpha compositing. You can look up alpha compositing and see the equations that are used for doing it.
I would love to see a comparison sometime. You basically paint them and as opposed to the screen, because again, the stars look fine doing it the way, you know, I've discussed, and so I just like to see if there really is a noticeable difference.
Well,
Maybe I'll work on it myself.
yeah, there's no one way to do anything in image processing. The same objectives can come out any way you want. Plus the fact, as I contend, we're not doing science, we're making art.
Yeah.
Making art, pretty much anything goes. So if you're happy with what you've created, you're doing it right. It's that simple.
Alex,
Yeah.
I just wanted to mention that it was John Murphy was the person that did that normalized gradient script.
Oh, yeah. That's right. Yeah. Yeah. And it's a good program and it works very well.
All right, any other questions for Alex?
Well, I want to thank everybody for bearing with me. I know it's a whirlwind tour, but also not just to download, but if you have any questions, I'll field those as well. So send them along. You can post them on our website and I'll answer them there.
Great job.
Okay, nice job.
Thank you, Alex.
Thank you all.
A few final things here. We're always looking for topics for our monthly meetings. So if you have a topic that you're particularly interested in, especially if you want to volunteer to lead the discussion, please let me know. And we usually get most of our topics from folks who are participating. So again, we're always looking for topics. If you've got something in particular that you'd like to discuss or hear discussed, let me know. You probably are aware that we're planning to have a hands-on workshop later in the fall, in November. And we sent out a survey a couple of weeks ago and got pretty many responses to the survey. And we're kind of compiling the results of those responses to come up with what we're going to spend the time on during the hands-on sessions. But as you might suspect, PixInsight and PixInsight processes was one of the more popular topics on the survey. And again, what we're hoping to do is to be able to have short sessions that are dedicated to some specific topic of image processing that can be covered in about a half an hour, allowing time for questions and further explanations after that. And again, making it a hands-on project where you can either bring your own data or the presenter or group leader will have some data if you don't have any data for the particular topic that you're interested in, so that you can get a chance to actually try to do some of the things similar to what Alex was describing this evening. So again, we're still working on planning that. We may reach out to some of you for help. I know that a few folks did volunteer on the survey, and you can certainly guess that we'll be hoping that you'll be able to help out, but we may be reaching out to some others as well. So be looking for that in your TAA forum email in the next month or so. Any other comments or questions or images that you would like to share? All right, well, we've recorded this. It may take me a week or so to get it up on YouTube, but I'll try to do that at some point in the near future. And if it's okay with everyone, I think it's been about an hour, so we'll call it an evening. So thank you for your participation. We'll see you again in September.
Thanks, Greg.
Thank you all.
Thank you, Greg.
Have a good night.